Hello everyone. So let's try to discuss this type of question. Graph the following function on the coordinate plane below. Your score will only be based on what you draw on the graph. So blank graph means 0 points. For full credit, your graph must show the correct x-intercept and y-intercept if any, must have the correct asymptote if any, must behave correctly around the asymptotes, only crosses at the correct point and approaches from the top or bottom. So you need to specifically mention, show all of these things in the graph to get the answer. So I have a couple of questions here, and we need to answer them. Okay, we need to draw the graph of these questions. So see, what is this? This is x squared plus 5x plus 4 divided by x squared minus 16. So how do we draw the graph of this? I actually have this graph here. How do we draw the graph of this type of question? First of all, to draw the graph of these questions, first we need what? We need to find out the asymptotes, all the intercepts we need to find out, right? Then intercepts, and if there is x-intercept, then we need to find out the behavior, near behavior. And then if there is some holes in the graph, like all our usual process, okay? So see, we have x squared plus 5x plus 4. Is it middle term factoring possible here? So see, 4, from 4 we get 5x actually, 4 plus 1 equal to 5. So x squared plus 4x plus x plus 4 equal to, then we get the same thing, then we can put the factory middle term. And this is x squared minus 16. X squared minus 16 means you can write a square minus b square formula, 4 square, x square minus 4 square, 16 means 4 square, right? So x square minus 4 square, then x plus 4 and x minus 4 will come from this downside here. And from this actually you get some middle term factoring, and then you will notice that x plus 4 and x plus 4 will be cancelled out from the numerator and denominator, okay? And then x minus 4 will remain in the downside, and upper side something will remain. This should be x plus 1, x plus 1, x plus 1. So this is how we get this, like if you do the calculation. Then all the information, if you join together, then the graph should be, see, this is x square minus, as I said, x minus 4 will remain here. So plus 4, there at plus 4 there will be some vertical asymptote, and as you can see, in the numerator there will be some x, in the denominator there will be some x, which is same. That's why our horizontal asymptote will be y equal to 1. When our power is same in the x and y, in the numerator and denominator, then our horizontal asymptote comes just only from their coefficient, which is 1 and 1 here, which after the calculation also you will see the same 1 and 1 here. So that's why y equal to 1 is our asymptote, okay? Then there is a hole here in this graph. There is a hole here. The reason is you cancel out. Remember, we cancel out x plus 4, right, from the numerator and denominator. That's why at minus 4 there is a hole in the graph. There is a hole in the graph at minus 4. So this is this is how we draw the graph, and other things also you will get it, like why it is why in this this is cross, because you see the power is 1 here. After the cancellation you will see the power is 1 here. That is the reason. Then this one, if you try to solve, you will see this one x squared plus 11x plus 24. So power is 2 here. You can try to do some simplification. It will be 8x plus 3x then plus 24. So x plus 8 and x plus 3. It looks like x plus 8 and x plus 3 will be there. And down here x plus 1. As it is x plus 1, so we will get some vertical asymptote. This is plus 1, so vertical asymptote will be minus 1. And then some oblique asymptote will come from here. Oblique asymptote will get by long division, and we can do the long division, and then our oblique asymptote will be this red line here. To get the x-intercept, we have to put y equal to 0. That means this term equal to 0. So if we put this term equal to 0, so x plus 1 into this equal to 0. So x squared plus 11x plus 24 equal to 0. That means from the factor we will get the answer. Factor is, it looks like factor is x plus 8 and x plus 3. So one will be minus 8 and another one will be minus 3, our intercept. So 1, 2, 3, 4, 5. So we have 5 here, That means 5 means 20, so this means our 10. So we can just look at this, look at the graph to plot them correctly. Then we will have the x-intercepts are this, then we have the horizontal oblique asymptote we have here, and this is our y-intercept. We get the y-intercept by putting 0 here, 0 0 0, so 24 divided by 1. 24 divided by 1 means 24, and as you can see 50 is here and 0 is here, so 24 is somewhat in the middle. This is how we get the y-intercept. And definitely everywhere in all of the graphs there are some arrow sign in both direction, in all direction there are some arrow sign. They are continuous. Just I took the, like I just cropped it so the graph looks like this. So everywhere there is some arrow sign. Then for this question, this type of question is also x squared plus x minus 6. So this type of question also we have, yeah, we need to cancel out. We cancel out some term. That's why some whole came. Then x equals to then we have got this vertical asymptote and horizontal asymptote from the numerator and denominator analysis. Similar methods actually we are following here. So this is x squared plus x minus 6. So which combination is possible? Is it yeah, my plus 6x minus x. So plus 6x minus x. Yeah, so plus 6x. Is it the x squared plus x minus 6? If we factor it, what comes? X squared plus x. Let me do it in my. Let me do it here. So x squared plus x minus 6 means we can have like x squared plus 6. No, not 6. X squared plus 3x minus x squared plus 3x minus twice x minus 6. Oh, so then x plus 3 cancel out. For plus 3 we have got this this whole here, because plus x plus 3 and x, this term will be cancelled out according to the calculation. Then x minus 6 will remain. X minus 6 will remain because there is some minus 6, x minus 6 type no term comes here. X plus 3 type one term will come, and another one will be x minus 2. X minus 2. Another term will be here x minus 2. If you do the factoring, if you do the middle term factoring, this is simple middle term factoring kind of. X minus 2 will be there. So x plus 3 and x plus 3 will be cancelled out. Then from the remaining term we will find out the asymptote, etc, etc, everything we will find out, including their x-intercept and y-intercept. Y-intercept is here, x-intercept is here. Then if you join all the pieces together, you will draw the graph here. And of course for the graph we need to find out some additional points to understand where my graph is actually going. Okay, and this question also similar kind of approach we have to use. So oh, this will be small letter x, by the way. Small letter, all are small letter x. This will be small letter x, I mean same x here. So our horizontal asymptote will be y equal to 1, which is y equal to 1 here, and vertical asymptote will be x equals to minus 3. Minus 3 is here because vertical asymptote comes from here, downside denominator, so we will get it here. Then to get the y-intercept we have to put 0 here and 0 here. Then it is minus 1 by 3. This point is minus 1 by 3 here. And then to get the x-intercept we have to put this equal to 0. So we will get x equals to 1. X equals to plus 1 is here because this is 5. This is 5 and this is 0, so 1 is here because all the boxes is 1 1 in this case. So this is how we draw the graph. And how do we know that there will be some other graphs here? To understand it, we need to put some additional points. Let's say we have our asymptote here. Let's put minus 5 or minus 10 in the graph in this question. Minus 5 here, minus 10, minus 5 here and minus 5 here. And then find out y equal to what? You plot it here, then put minus 10 again. Y equal to what? Find it out, then plot it here. Then you will see some points here, which is showing us our trend of the graph, and we have some asymptote here. So we have, if we have some point here and some other points here, that means our graph will go like this because of the asymptote. Asymptote is telling us that our graph will come closer and closer and closer and closer to the asymptote, and this side also. So this asymptote and any 2 points or 3 points will give us the shape of the graph, and these 2 point will give us the shape of this graph. Actually we actually do not need any additional point this side if you understand that what will be the shape of the graph. Okay, and if you want, definitely you can put plus 5 here also to get this point. Actually if you want, you can put. So this is how we actually draw, the graph of rational function. But drawing the rational function sometimes takes time, But for this kind of question, it should be pretty much easy, because there is no like very gigantic kind of simplification needed here. These are simple simplification, simple maths to some degree, actually. Anyway, all right, thank you all, thank you very much. I hope it the entire process helps a bit. Okay, bye bye.